All right, this video tutorial is on the Big Ideas Geometry section 5.2 titled Congruent Polygons. Two learning objectives for this one, to be able to identify and use corresponding parts. We've already very briefly talked about corresponding angles when it comes to parallel lines and transversals. These are going to be very similar in using the word corresponding and using the third angles theorem. So main thing to talk about today is that in congruent polygons, corresponding sides and their corresponding angles are congruent to each other. So when we talked about parallel lines and corresponding angles, the key phrase that we talked about is that they're facing the same direction. However, in polygons, it's really going to be based on the markings that you're given. Notice how in these two triangles, it seems like they're facing opposite directions. However, each angle is given different marks. So angle A and angle D both have one arc measure on them. Those two angles are corresponding to each other, and that means that they're congruent since the whole polygons are congruent to each other. Same thing with angle B and angle E. They both have three markings. So those two are congruent. C and F have two markings, so those two corresponding angles are congruent. It also works with sides based on how many markings are on each side. So CB right here has one, EF has one, so that's why right here we have BC and EF. Using the reflexive property, you can rewrite those in a different order. Yeah, so anything that has the same markings, those are going to be considered corresponding to each other. So write a congruency statement for the triangles and identify all pairs of congruent corresponding parts. So a congruency statement is an equation that uses the congruency symbol to say that this triangle is congruent to this triangle. That's what our end goal is here. And then to also identify all of the corresponding parts that are congruent to each other. So to figure out which parts are corresponding, we can either look at just the given marks, or we can rotate this triangle around so that they are facing the same direction, so that it's set up similar to how our parallel lines were, where things are facing the same direction. So the diagram would tell us then that triangle JKL is congruent to TSR, and the order is going to matter. So your first one is set up as JKL. You need to make the exact same motion for your second one, TSR. You could change the order of the first one. You could say JLK, but then your second one would have to also match and be TRS. So the first order doesn't matter, but your second order has to match your first order. Then as far as the corresponding angles, you're just going to write out which angles have one mark, they're congruent to each other. So the two marks right there, J and T, K and S are the three marks, and L and R are the one marks. And then you're going to do the same thing with the sides. JK and TS have one dash mark, and you've got KL and SR have two dash marks, and then JL and TR, or LJ and RT, are your three marks. So those are all of your corresponding angles and corresponding sides. All right, moving away from a triangle and just looking at different types of other polygons. So this is a quadrilateral. You're given that the entire quadrilateral on the left is congruent to the one on the right in that order. So DEFG is congruent to SPQR. So it does look like it's flipped, but if you look at each individual side, you can figure out which parts are congruent to each other. So in order to find the value of x, let's look at where our first x is. We've got an x right here on QR, which is tx minus 4. Looking at your congruency statement, QR are the last two letters. So that would mean that your corresponding part over on the left side would also be the last two letters, which is FG. And FG is down here at the bottom, which is this 12. So even though it's flipped, your congruency statement tells you each parts that are congruent to each other. So you're going to set up an equation that says 12 equals to 2x minus 4, because you know that those two parts are congruent. And then you use simple algebra to get the x by itself. Add 4 to both sides to get 16, and then divide by 2 to get 8 for your value of x. Because now we need to use this x in order to help us find the value of y right here. So this is an angle measure at angle Q, which is the third letter. We're going to use that to set it equal to the third letter of the first one, which is f, and f is 68. So again, our equation is going to be set up where angle Q is equal to angle f. 68 is equal to 6y plus x. Again, we already know what x is, so let's plug the 8 in over in the x space. Take away 8 on both sides, and then divide by 6 to get 10 for your y. Okay, moving on to other types of congruent polygons. So you're going to take a wall and divide it into orange and blue sections for what looks like a paint project. And that line segment is going to be called JK. Will the sections of this wall be the same size and shape? So let's explain if this would. Well, first thing we can look at are the angle measures. Ideally, when you're looking at walls and you're painting them, that your walls are going to have 90-degree angles. So angle A is going to be congruent to angle C based on your diagonal line and that it's rotating that shape. Because all right angles are congruent to each other, those are your corresponding angle parts. And then also because we have a transversal and parallel lines, the ceiling part and the floor part are going to be parallel to each other. So because the lines are perpendicular and using the transversal theorem, you can say that those lines are parallel to each other. Then we can also figure out by the alternate interior angle theorem that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3. Notice that they're on different sides of this transversal, or the line that's cutting in a different shape. You can conclude that those two are equal. So we're going to go ahead and mark those right there on the picture. So all the pairs of corresponding angles are congruent. Now we need to get to the sides. The diagram does show that line AJ up here has 1 marking and CK down here has 1 marking. KD, which is the long one on the orange side, JB, the long one on the blue side, AD, the vertical on the orange side, and BC, the blue on the vertical. And then based on the reflexive property of congruence, this line JK is congruent to this line JK. It's congruent to itself. It just depends on the perspective of whether you're looking at the JK in order for the orange, or then back up in the reverse KJ for the order of the blue. Those two lines are congruent because they're the exact same line, so that's where using the reflexive property is going to help you conclude that. So you're just going to give that mark that it's congruent to itself. So based on all of that information, you can say that all pairs of corresponding sides are congruent, and since all angles and all sides are congruent, you could say that AJKD is congruent to CKJB. Again, the order of the first one does not matter. The order of the second one has to match that. And you can think about what the side lengths are going. So for AJ is 1, then JK is 4, then 2, then 3. So you need to go the same order, 1, 4, 2, 3 to write the order of the second one. All right, so a couple theorems. We've talked about the reflexive property already in that last example. Symmetric property is another one that we're going to be using. That just tells you the order of the different triangles. So it's not changing the letters inside the shape. It's just saying that if triangle 1 is congruent to 2, then 2 is congruent to 1 as a whole. Transitive property is including a third triangle. So if the first triangle is congruent to the second, and the second is congruent to the third, then the first is congruent to the third. So going back to our if-then statements with our biconditionals and our conditional statements, these properties are going to be important to help prove things congruent. Third angle theorem. Let's say you have 2 angles of a triangle, and you know that they're congruent to the 2 angles of another one. Like in this diagram, A is congruent to D, B is congruent to E. Well, based on the triangle angle sum theorem, you already know that the third angles of both of those triangles also have to be the same. You're taking away 180 from the exact same numbers of A and B. Since they're the same as D and E, you're going to get the same left over for C and F. So those third angles are going to be congruent. All right, so finding the measure of an angle inside of a arrangement of triangles where you're given congruent parts for angles. So based on the diagram, you know that A is congruent to B, and that triangle ADC, which is this one right here, is congruent to BCD. So by the third angle theorem, you know that angle ACD, which is this larger one down here that includes both of them, and this larger one down here are going to be the same. And then by using the triangle angle sum theorem, you're just taking all of those and adding them up to 180. So 45, 30, and your ACD all have to add up to equal 180 degrees. So when you take those all away, you get 105 for your ACD. But remember, we're trying to find BCD. And since those two are congruent to each other, you know that 105 is also the same as this one over here. All right, so moving on to prove that two triangles are congruent to each other. So this is going to be kind of a sneak peek on what we're doing for the rest of this unit. And we'll just introduce more theorems on how to prove that two triangles are congruent. So we're trying to prove that in this order, ACD is congruent to CAB. And this one, the order does matter. You can't change it because that's what your final proof needs to look like. So we're going to identify all of our given information based on the diagram. So all the sides that are marked the same, we're going to write our congruency statements. All the angles that are the same, we're going to write our congruency statements for those. And our final goal is to prove ACD is congruent to triangle CAB. So here's what we can do. We do know, based on how this looks similar to that wall paint problem, that we can use the reflexive property to say that that line AC in the middle is congruent to itself, and just depends on the order in which you go A to C or C to A. We're going to be using that. We're also going to be using third angle theorem because we can see that two angles are marked congruent. So that must mean that the third angle, B and D, are going to be congruent to each other. So let's just kind of put that all together in our two-column proof. Remember our statements and reasons. Always start your statement with your given information. We're going to do it just with the sides first because we're going to prove the sides. So then we're going to use and introduce our reflexive property that we have AC and CA are congruent. So based on those three, we're going to move on to the angles as our given information, and then talking about our third angle theorem. You know that B is going to be congruent to D because of the third angle theorem. And then since you have all of your corresponding parts labeled out, all three sides are congruent, all three angles are congruent, then you can say that triangle ACD is congruent to a triangle CAB.